The state of Minnesota, home to 5.8 million people, is quite a geologically fascinating location to live in. For example, the state contains rock units spanning 3.55 billion years in age and even contains abundant banded iron formations deposited from a time when our planet's oceans ran red in color. Yet, the most striking feature that Minnesota is known for is its absurdly abundant lakes, being colloquially known as the land of 10,000 lakes, with this phrase even appearing on Minnesota's state quarter. I want to note that for this video, we are only counting naturally occurring and not human-made bodies of water which contain an area of 10 or more acres as lakes, or more than 0.0405 square kilometers. With this in mind, Minnesota contains 11,842 lakes, a total even higher than the combined total number of lakes in 6 adjacent states. And this figure isn't simply owed to Minnesota's size, as shown if I adjust the diagram to show the average area needed in square miles to contain one such lake. So, how exactly did Minnesota end up with so many large lakes? The answer involves glaciers, as almost every single one of the state's lakes are glacial in origin. For example, if you had stood in Minneapolis a mere 20,000 years ago during the planet's last glacial maximum, when glaciers covered 25% of Earth's landmass, you would have been buried by 3,000 feet thick of glacial ice. Not only that, but at the time, a whopping 82.4% of the state was covered by a massive, still advancing ice sheet. I want to note that not only is this more substantial than all other adjacent states I previously mentioned, but that some models suggest the entire state was covered in a thick ice sheet at the time. And even if only 82.4% was, the entirety of the state was covered at some point by a glacier during the more than 24 glacial periods which occurred between 2.58 million and 11,700 years ago. As these glaciers advanced, they naturally flowed into lower points in the landscape. When this occurred, they carved into and pulverized large amounts of underlying rock, creating deep valleys which would later fill with lakes such as Greenwood Lake and Newfound Lake. However, the vast majority of lakes formed via 2 other methods, only truly forming once the last glacial maximum waned and glaciers started to retreat. As these glaciers retreated, they left behind the trillions of tons of rock and sediment which they had carried, with some of their material being emplaced at the furthest extent and at the sides of glacial lobes via structures known as moraines. However, most material was simply emplaced in an uneven manner as glaciers retreated, and since this glacial till was emplaced in uneven amounts, it formed depressions in the landscape which would form many small lakes. Yet, while the prior 2 explanations did create some lakes, the vast majority of the lakes within Minnesota were created by a third process. During glacial retreat, chunks of glacial ice ranging in size from a small boulder to 8 miles wide occasionally broke off and were left behind by the retreating glacier. They were later buried by loose sediment dropped from other sections of the retreating glacier, and thus, when these pieces of ice finally melted, they left behind a depression in the ground. And if this depression dipped below the water table, the kettle filled with water. If not, it could still serve as a low point which would eventually naturally fill with water during subsequent rainfall and snowfall. This is why large sections of Alaska, Canada, Russia, and Minnesota that used to be covered by numerous glaciers have many thousands of these features known as Kettle Lakes. As a final note, I would like to thank my new patron SR Carfelt for supporting this channel.